let's take a look at our unit assignments so that we can maybe use what we did right, what we did wrong to help us a little bit for tomorrow's test. Start with the written response here. Question number 1 says a 400-gram football is thrown at a speed of 12 meters per second at a height of 1.75 meters above the ground. Determine the magnitude of the momentum of the football as it strikes the ground. First thing I did there was circle the grams, right? We want to be in kilograms, and I think all of you guys did that. I think all of you guys converted from grams to kilograms, but it's a good idea to draw attention to this anyways. Listen, you guys are going to have your test photocopied for you tomorrow. It's not online or anything like that. It's a paper copy. You guys should mark that up like crazy. Underline things, highlight things, circle things. Okay, I'm not going to use that again, so you might as well mark it up. You might as well wreck it, okay, with your little notes to remind you of little things like this. So this football is thrown at a speed of 12 meters per second. We don't actually know which direction it's thrown, but since we're only looking for the magnitude of the momentum, it doesn't really matter. If we wanted the momentum including direction, we would need to know whether it was thrown at an angle or whether it was thrown downward or whatever. You're not going to have to worry about a question like that. Okay, question for us, it's either going to be thrown upward or downward, in which case you don't have to worry about a two-dimensional thing, or you're going to be looking for just the magnitude of the momentum, and that way you don't have to worry about a two-dimensional thing either. So a question you could get might look similar to this. All right, we know that we've done questions like this before. We know that this is one of those momentum after acceleration questions. We find the momentum, or the final momentum, by saying m times the final velocity. But we got to find the final velocity. Now, there's lots of equations that we could use to do this. All of those acceleration equations that you learned in physics 20, but also EI equals EF, kinetic energy, potential energy. Listen, guys, the way that most of you seem to like to do this is VF squared is equal to VI squared plus 2AD. So I'm going to do that. We're looking for the value of VF here. It's the square root of VI squared. Now, here's the first mistake that people make on this. Some of you will forget to include the VI tomorrow if you get a question like this. VI is 12 meters per second. Sometimes it's just dropped. If it's just dropped, VI is 0. But if it's thrown, then VI is something, in this case, 12 meters per second. More of you will make this mistake tomorrow, forgetting to square the 12, or whatever number it happens to be. Do not forget the little things. Watch those little things, right? We know it's VI squared, but when we punch it into our calculator, sometimes we forget to hit the square button. All those little details, right? 2 times neg 9.81, my displacement would be negative 1.75. One or two of you did all this right, but said the displacement was just 1.75. That's a problem, because then that gives us neg 9.81 times positive 1.75 gives us a negative number. Negative times a negative gives us a positive number. If I say 12 squared plus a negative number, 12 squared plus a positive number, gives me two completely different numbers, right? So watch that. It's negative, by the way, the 1.75, because it falls downward. It ends up below where it started. I solved for this. The speed here is 13.3542122 meters per second. That's the final speed, not the final velocity. If it was thrown straight down, the final velocity would just be negative 13. We don't know which way this is thrown, so we don't know what the velocity is here. Because we don't know if it's thrown down or up or at an angle or whatever. In the end, it doesn't matter, because we're only looking for the magnitude of the momentum. So we're going to multiply 0.4 kilograms times the magnitude of the velocity, or in other words, by the speed. And when we do that, we get a value of 5.34 kilograms meters per second. That's a 2-point question. Number 2, by the way, if I do happen to go too fast and you need me to wait, pause a second, just tell me and I'll do that for you. Number 2 says a 430-gram soccer ball. Here we go again with the grams. You know that's going to happen tomorrow, right? We're going to see something in grams. We have to convert it to kilograms. Moves towards a man's foot at a speed of 12 meters per second. After the man kicks the ball, the soccer ball moves off at the speed of 15 meters per second in the opposite direction. I still got the red pen in my hand. What do I want to do with the red pen here? What do I want to draw attention to in this question? I haven't even read the whole thing yet, but there's already something that I want to draw attention to. Man kicks the ball. The soccer ball moves off in the speed of 15 meters per second in the opposite direction. Opposite direction. Why is that important? Some of you made this mistake as I was marking your lab or your assignments. I noticed that some of you made this mistake. If it's the opposite direction, one of these must be positive and one of these must be negative. And it doesn't matter which one is which, as long as they're opposite signs, opposite directions, opposite signs. Time of contact is 0.4 seconds. What's the impulse that the man's foot provides to the soccer ball and the force of impact that the man's foot provides on the soccer ball? All right, impulse is equal to m times delta v. It's also equal, here, let me write this down actually first. Impulse is equal to f times delta t, which is also equal to m times delta v. Now, only this part appears on your data sheet. Remember when we did this, I asked you to write down beside that, right on your data sheet, delta p, impulse. Tomorrow you're going to be given a clean data sheet, a brand new data sheet. It's going to look the same as what you have, minus whatever you wrote on your data sheet. What I would suggest you do when you're allowed to start writing your test is write little things like this. Write all over your data sheet. If it's helpful to write delta p beside it, then write that. If you've written other things on your data sheet that are helpful to you, then write that on your data sheet tomorrow. Whatever was helpful to you in homework questions, do it on your data sheet for your test so that it's helpful for you in your test as well. All right, we're going to use part of this for this question. Impulse is equal to m times delta v. My mass is 0.430 kilograms, and my change in velocity is, be careful here, it is not 15 minus 12. The change in velocity is either, the final is 15, right? But it's either negative 15 minus positive 12, or it's 15 minus negative 12. In both cases, while we get negative 27 here, we would have gotten positive 27 the other way. We do this, by the way, we get an impulse of negative 11.61 Newton seconds, which we actually should round to 3 digits, negative 11.6 Newton seconds. If you define negative the other way, then you would have gotten a positive 11.6 Newton seconds. This doesn't really matter as long as you're consistent for your question. Now we're looking for the force of impact of the man's foot on the ball. We already have the impulse. Now let's use impulse is equal to f times delta t. And just divide that impulse by the time. I get negative 11.61 Newton seconds divided by the time of 0.400 seconds. And that gives me a value for the force of negative 29.0 newtons. Now, I didn't ask you this, but I could have. I could have said, what's the impulse of the soccer ball on the foot? I asked you what's the impulse of the foot on the soccer ball, right? What's the answer to that question? What's the impulse of the soccer ball on the foot? The impulse experienced by the soccer ball is negative 11.6. The impulse experienced by the foot is positive 11.6. The impulse is equal and opposite? Yeah. Always equal and opposite? Yeah. Tomorrow, I told you this before. I'll tell you again. Tomorrow I'm going to try to trick you into thinking the impulse isn't always equal and opposite. At some point on that test, you're going to be like, oh, I think it's this one. It's not. The impulse is equal and opposite. It doesn't look like this, okay? But just remember what I just said, okay? The impulse is always equal and opposite. That's going to help you out with that question when you see it. Force is always equal and opposite as well, right? If the force on the soccer ball is negative 29, well, then the force on the foot would be positive 29, right? I don't remember if the force, the equal and opposite force thing, appears on tomorrow's test or not. I do remember the equal and opposite impulse thing does appear on the test. Let's take a look at number 3. Now, I apologize for this. The answer isn't particularly realistic. I don't know how many of you noticed that. You got a young girl applying a force on a 75-gram toy car over a period of time as described by the graph. Toy car begins at rest. We want to draw attention to that, right? Because sometimes it does not begin at rest. There's a multiple choice question that you guys had that's real similar to this, where it didn't begin at rest. It had a certain initial velocity. So if it does have an initial velocity especially, circle it or underline it or something to draw attention to it. Okay, I see a force versus time graph. And every time I see a force versus time graph, 3 words should come to my mind right away. What are they? Area equals impulse. Every single time. Area equals impulse. There's sometimes other things that I have to do as well, but I know I'm going to have to do area equals impulse. Now, what I did is I broke this into 3 sections. A triangle, although some of you broke it into 2 triangles. Doesn't matter. Another triangle, and a rectangle. I don't think I saw this from any of you guys when I marked your assignments, but I sometimes see this. People start trying to calculate this area in here. You want the area between the line and the x-axis. Doesn't matter where it is, between the line and the x-axis, not outside of that. All right, let's get this. Area 1 is 1/2 of the base, which is 3. Oh, sorry. I should also notice the units here. Seconds and newtons. Okay, we're good here, right? Every graph we ever do, we should look at the units to make sure we're understanding. If we're not, then you got to convert them. Okay, the base here is 3. The height is 10. That gives me an area of 15 newton seconds. The second area is also a triangle. The base goes from 3 to 4 is 1. The height goes from 0 to -10. Oh, would you look at that? -5. How come it's negative? How come it's negative? Why is that area negative? How can you have a negative area? Yeah, it's below the x-axis. Okay, the impulse is negative, the area is negative because it's below the x-axis. Good. The third area is base times height. It goes from 4 to 6, which is 2 for the base. The height is 10, -10, I should say, which gives me, is that -20? We add those up, and we get, I think, -10 newton seconds as my area. Now, we're actually looking for the velocity of the toy car at the end of this after 6 seconds. That's fine. Listen, I wasn't asked for the impulse, but I always got to do it. What else can you do besides the impulse, or the area, I should say? What else are you allowed to do for this graph? Remember this, delta P is equal to M times delta V. What are you not allowed to do for this graph, or any other force versus time graph? Don't use F times T. Remember I gave you a question one day in class. It wasn't a quiz or it wasn't a practice quiz, just a question we worked on in class where you wanted to find the maximum force. Remember that? And you remember how lots of you were tempted? Lots of you did use F times delta T. I tricked you into using F times delta T. Don't let me trick you. Okay, you know what to do. Area equals impulse, M times delta V, that's it. Now in that question, you kind of had to work backwards and find impulse first, and then go back with the area and find the height. Okay, but in the end, it was still the same 2 things that we did. My impulse here is -10. My mass is 0.075 kilograms. That gives me a delta V of -133 meters per second. That's a fast toy car, 133 meters per second. Okay, it's a strong girl. Good. The numbers that you get on questions tomorrow will be realistic. I somehow missed this when I was making this one. Number 4. An 85-kilogram football player running at 6 meters per second to the east collides with a 90-kilogram football player running to the west. East and west. We see that all the time. East and west, we don't need to worry about X and Y components, but we do need to worry about positives and negatives. 2 players head off as one object after the collision. I like it when that happens. It means less terms. We have 2 objects before, 2 terms. M1V1I plus M2V2I. We have 1 object after because the football players, they're embracing and heading off as one. They are one with each other. The mass of the first one, before he, well, I was going to say he, could be a she, could be an 85-kilogram female football player. 85 kilograms, the mass of the football player, 85 times 6, plus second football player is 90 kilograms times negative 7.5. You see how important it is to include that negative? That number on the left-hand side of the equation is going to be wrong if I don't. You know what you're doing here, but you still get a 0 to 1 on the question if you forget that negative. Little things, right? Details. Total mass is 175 kilograms. So get this number over here, divide it by 175, and we solve for VF. And when we do, it works out to be negative 0.943 meters per second. Some of you said 9.943 meters per second to the west. Is that okay? Of course it is. In fact, if this is a multiple choice question on a test tomorrow, it likely wouldn't say negative 0.943. It would likely use the west term, right? Or it would ask you to solve for the magnitude of the velocity, one of the two. Yep.
So I'm just wondering, what I did is I didn't put the negative on 7.5, but
Yep.
I did it in opposite direction, so I subtracted the 90 times 7.5. Would that be full marks?
Yep.
Alright, thank you.
Yep. So if you didn't hear that, guys, the question was, you structured it a little bit different here. Just calculated this momentum, and then said calculated this momentum, the 90.7 times 90 times 7.5. Calculated them both as positive, but subtracted them. Right? Does that make sense? I'd shy away from that, to be honest, because total momentum is a sum, but it's the same, mathematically it's the same thing. And I'd mark that right, because it's not a coincidence that you got it right. You're there? All right, number 5. Number 5. I'm actually going to make a little bit more space on number 5 there. It says, a 1,000 kilogram car traveling north at 36 kilometers per hour collides with a 1,200 kilogram car traveling west at 54 kilometers per hour. North and west. North, west. Now I got to do X and Y components, right? Now I got to break it up. Always, unless you're dealing with kinetic energy. If it's an elastic, inelastic question, you don't need to worry about breaking that up into X's and Y's. Okay, let's draw this out. I'm going to say the 1,000 kilogram car traveling north, 36 kilometers per hour. And I got another car number 2, 1,200 kilograms, and it's traveling to the west at 54 kilometers per hour. Listen, we're going to predict this wreckage is going to go off like this. So that is right. But even if I did guess wrong, it's okay. The one you're solving for, it's okay if you don't have it drawn right. All right. I was a little surprised, to be honest. There was 3 or 4 of you that did not convert kilometers per hour to meters per second. Most of you did, but a few of you didn't. Is it okay not to convert? Is it okay to leave it in kilometers per hour? Yes, it is. It is okay because the units cancel with conservation of momentum. If you're doing anything else like impulse, you have to use meters per second. The conservation of momentum, you can use meters per second or kilometers per hour. When I do this, I will do it in meters per second only because most of you do. But kilometers per hour is fine. Here's what we do. X component, pi equals pf. I'm going to say 0, because object number 1 is on the y-axis, plus m2 times v2I equals mass total times vf. Now, 54 kilometers per hour is in meters per second, 15 meters per second. Take the 2200 over dividing, and we get VF is equal to, for the X component, negative 8.1818 meters per second. And for the Y component, it's almost the same thing, right? PI equals PF. We'll say this time M1 times V1I plus 0, because object number 2 is only on the x-axis, equals MT times VF. 1,000 times 10, 36 kilometers per hour is 10 meters per second. Solve for VF there, and VF for the Y component works out to be 4.54. Now we just redraw it. Get 8.18. We got 4.54. And then we got my resultant vector right there. Square root of 4 squared plus 8 squared gives me 9.36 meters per second. And theta is the inverse tan. What's the opposite side here? Is it 8 or is it 4? What's the opposite side, Tara? What's the opposite side, 8 or 4? It's 4, yeah. Calculate that, it works out to be, I got 60.9, oh, no. Actually, just notice it on my answer key. I actually did it opposite to that. I drew the vertical, then the horizontal. And when I did that, I got 60.9. But if I draw the horizontal first, then I shouldn't get 60.9. I should get 29.1 degrees. So with the way that I have it drawn here, it's 9.36 at 29.1 degrees north of west. The way that I did it on my key, it was 9.36 at 60.1 degrees, 60.9 degrees west of north. And of course, both of them are correct. Okay, in the test tomorrow, multiple choice, it'll specify. So you may have to subtract from 90 to get the one you're looking for. How are we doing, guys? So far, so good? Number 6. Number 6 asks us to repeat question number 5, the one we just did, but this time the 1,000-kilogram car is traveling north of east. So car number 1, 1,000 kilograms, is going like this, 30 degrees north of east, at a speed of 36 kilometers per hour, or 10 meters per second will make it, because most of you did it in meters per second. Car number 2 is still going to the west. Its mass is still 1,200 kilograms, and its velocity is still 15 meters per second. I'm going to predict that this wreckage is going to go up here somewhere, but if I predict wrong, it's not a big deal. The math will tell me that I was wrong. Now, earlier in this assignment, I said there was 3 words that I want you to automatically think, and you guys knew those, right? It's a force versus time graph, and you guys thought area equals impulse every single time. When I see this question, there should be 5 words that come to your mind every single time. What are they? Okay?
angles.
I don't like funny angles. Good. So let's get rid of it then if we don't like funny angles. Take that funny angle off to the side here. That's 30 degrees, 10 meters per second. Let's replace it with an X and a Y. Which side of the triangle? Claire, which side of the triangle is the X side there? Is that opposite or adjacent? Yep. So which trig function are we going to use? Adjacent and hypotenuse? Yep. Good. Cosine 30 degrees is equal to adjacent over 10. And that's going to give me 8 point, I'm trying to find it here. I think it was 8.66. Yeah, 8.66025. And the y component, this one's easier, sine function. And then we just box it off, or at least I do, because it's comfortable. Tomorrow's a multiple choice / numeric response test for you. You're going to get your written response test in another month or so on this stuff. But even tomorrow on the multiple choice numerical response test, like, do all this. Okay, don't look at that test and say, I'm just going to rush through the solutions. Like when you're doing homework, you write down stuff like I'm writing it down here. So do that tomorrow. If you play a sport, basketball or hockey or baseball, and you're practicing, your coach has you doing certain things in your practice the way that he or she wants you to do it in the game. You don't practice sloughing off. You practice the way you want to play. Well, we practiced this way, right? When we were doing our worksheet questions, we showed all our work like this. Why? Because that's the way we want to play. Tomorrow's game day. Don't start regressing on game day. Like, do it the way you do it in practice on game day. Okay, show all the work. I don't need to see all the work, but show it for yourself, because it means you'll have less chance of making a mistake, right? That routine that we've gotten used to. All right. I'm going to actually replace this. I don't like this anymore. Get out of my life forever. I got my 8.66025, and I got my 5.0 meters per second up this way. Now all I've got is 90-degree angles. I've got normal angles, right? It's not a coincidence, actually, that we call them normal angles. Okay? I got funny angles and I got normal angles. What does normal mean in physics? Physics 20. When did you use that term normal in physics 20? What is it? The normal force. The normal force was at? The normal force, what angle was the normal force at? Always. 90 degrees. Is that 90 degrees? Normal means 90 degrees. In physics, normal means 90 degrees. So these are normal angles now versus funny angle, like we had before. That's good, because we can deal with normal angles easier. Okay, now let's do x and y components. Let's say pi equals pf. Let's say m1 v1i plus m2 v2i equals, they stick together. If they didn't, no big deal. We just get two terms afterwards as well. M1 is 1,000 times v1i is 8.66025 plus M2. V2i, careful here, is negative 15. Negative because it's to the left. The 8.66 is to the right, so it's positive. The 15 is to the left, so it's negative. The total mass is 2,200 kilograms. Solve for VF there, and it works out to be negative 4.25. Good. I think it's good because most of you got that. The y component, we do almost the same thing. Pi equals Pf. M1 V1I plus, I'm actually going to put a 0 in here because object number 2 is not on the y-axis. It has no y component to it. Equals mt times Vf. This one's easier because there's only 2 terms total. 1,000 times the y component of that initial velocity. Remember, it's not 10 because that 10 is dead to me. 5.0 meters per second. Equals 2,200 times Vf. Vf is equal to, I think it was 2.25. Yep. So we're going to say 4.25, 2.25, we're going to solve for V. The Pythagorean theorem there gives me a V of 4.82 meters per second. And theta, the inverse tan of opposite over adjacent. What's the opposite side here, Liam? Is the opposite side 2.25 or 4.25? Good. 2.25. That gives me an angle of 28.2 degrees. And we call that north of west because we're measuring that angle from the west. But we could have just as easily drawn the y-axis first, then the x-axis. In that case, we would have got 61.8 degrees. 61.8 degrees west of north. Again, on tomorrow's test, it could be either one. If it's the opposite to what you have, just subtract it from 90 degrees. What could I have done on this? We talked earlier about the little things, right? Reading the question, knowing what you were being asked to find. What could I have kind of tricked you on this question? What could I have asked you to find that would maybe trick you a little bit? Yeah, I could have absolutely asked you for the momentum. A lot of people, when they see that, don't read that carefully because we're so used to finding the final velocity, right? We usually do find the final velocity. So that's where we usually stop. But sometimes you're not asked to find the final velocity. Sometimes you're asked to find the final momentum. Oh, I got one for you. I got another one for you here. What if I didn't say, what if this question didn't say, what's the final momentum? By the way, if you wanted to find the final momentum, Dave, how would you do it?
Take the final speed multiplied by
Yeah, that's right. The final velocity multiplied by the mass. Good. Easy, right? What if the question didn't say what's the final velocity? It didn't say what's the final momentum. What if the question said, what's the initial momentum? How would we do that? How would we do that? What's the initial momentum? Let me give you a hint. It doesn't have to be hard. Anybody have an answer for me? It is staring you right in the face, literally. The initial momentum is the same as the final momentum. Don't let me trick you with that and have you do some kind of craziness that you're like, I don't know how to find the initial momentum. Let's do this. Like, the initial momentum is the same as the final. If you're asked for the initial, well, if you can get the initial easier, then do it. But if you can't, then just do what we do, get the final, and that's going to be the same as the initial. I can't remember if I asked you that or not. Finally, number 7 that we want to go over here. Where is it? Number 7. Here it is. Determine mathematically whether the collision in question number 4 is elastic or inelastic. It wasn't actually supposed to be question 4, and some of you did use question 6 because it makes sense, right? That right after question number 6. Okay, some of you actually did question number 5 because number 6 referred to number 5. So there was answers all over the place on this, and I didn't penalize anybody because of that. I didn't actually intend it to be question 4. But in the end, if you did the right thing, you got full marks for this, 2 out of 2 for this. We would say EKI equals 1/2 m1 v1I squared plus 1/2 m2 v2I squared, if there was two objects, right? With sub in our numbers, we get an initial kinetic energy. Now, what a few people did, to no surprise of me, what a few people did was forget to square the speed. Okay, if you forgot to square the speed, that's okay. Give it to your system. Learn from your mistakes. Try to avoid making that mistake tomorrow. If you do, it's not the end of the world, but try. Learn from your mistake and don't do it again. We calculate EKF. If they bounce apart, then this is the way it looks. If they stick together, then there would just be one term. Again, don't forget to square the speed. I'm not going to give you numbers here because, again, different people use 4, 5, and 6 as the reference question. And we determined these kinetic energies, and in all three of those, we would have found that the final kinetic energy was less than the initial, which means the collision is inelastic. If it's the same as the initial, then the collision is elastic. If it's more than the original, then you've made a mistake, because it won't be more than the initial kinetic energy. Okay, let's do the multiple choice questions now. This is similar to one we already had. A lab cart, negligible friction, has a mass of 0.95, is moving at a velocity of 1.2 to the south. That's important. The fact that it has an initial velocity, right? In that other question, the written question, the response, we did not have an initial velocity. Some people got the wrong answer because they forgot to include that. So on and so on and so on. Look, there's a force versus time graph. Area equals impulse. This one's easier to find the area. Just 1/2 of the base, 0.8, times the height of 4.5. So, look, the units are standard, so all we got to do is multiply the numbers we have there. I don't have that number on my sheet here. Anybody got that? 1/2 of 0.8 times 4.5? What is it? 1.8? 1.8 newtons a second. Now, we weren't looking for the impulse, but we're looking for the velocity. So let's say delta P is equal to m times delta V, the other thing that we can do. Delta P is 0.8, and my mass was, what was my mass? 0.95 kilograms. And that gives me a change in velocity. I believe it was 1.9. Is that right? Yeah. 1.9 meters per second, which is not the answer. Some people put B for that. I get that. You get 1.9, it's there. It's got to be my answer, right? But again, the details, little things, read the question. Answer the question. The initial velocity was 1.2 to the south, negative 1.2. So to find the final velocity, we've got to take the change in velocity, 1.9 meters per second, and we got to add the initial velocity, which is negative 1.2. When we do that, it gives me, if I hadn't around it there, it would have given me 0.69 meters per second. And that should make some sense, right? If this thing comes in, what is it that comes in there? A lab cart comes in and hits the wall at 1.2 meters per second. It's not going to bounce back at 1.9. Remember what we said just a minute ago? If kinetic energy is gained, you're wrong. If you got a collision, kinetic energy is gained, then you've made a mistake. Okay? Well, if we strike it at 1.2 and it bounces off at 1.9, you've gained kinetic energy. Because one object has gained kinetic energy, and that can't happen. So you must have made a mistake. 0.69 to the north. Now the next question says, because the cart bumper system has negligible friction, in other words, what are they trying to tell you there? Negligible friction. Right? No external forces, right? That's our definition of an isolated system, no external forces. Because kinetic energy in this cart bumper system is not conserved, right? We went from 1.2 to 0.69, then it must be an inelastic collision. The answer will be A for that. 3. Automatic braking system in these cars designed to activate if the car encounters a sudden head-on force greater than or equal to or greater than 1.25 times 10 to the 4. In which cars would the braking system activate if each vehicle were forced to stop from 100 kilometers per hour in 4 seconds? How many of you guys did this? How many of you guys calculated the force 5 times for each of these? Yes? Anybody else? Yeah, there must have been more than a couple. That's a good method. It's more work than you have to do, but that's a good method. It works. You get 100 minutes tomorrow if you want, right? Like, you got all the time in the world to do calculations like that. There is a shorter way to do it, though. I mean, by all means, do that using impulse. But there is a shorter way. I can use this data to solve for a mass. So what we say, 1.25 times 10 to the 4. This is the force, right? The threshold force, we'll call it. The time is 4 seconds divided by 27.7777. Actually, the force is negative, and so is the change in velocity. It gives me a mass of, I think it was 1,800. I should calculate that. I think it was negative 1,800. I'm sorry, positive 1,800. So what we're saying here is this. If you got a mass that's bigger than 1,800, then your force will be bigger than 1.25. So I'm looking for forces that are bigger than 1,800, which means the answer would be 2, 4, and 5. D is our answer. How many people did it that way? Nobody? Oh, interesting. How many people did it this way? How many people said, well, each of my options have 3 masses. It must be the 3 heaviest. So it must be 2, 4, and 5. Done. Good for you. Just be careful that you know how to do the question otherwise, because maybe next time one of the options has 3 and one of them has 2, and you're like, then you have to do a calculation, right? But more power to you if you can notice little things like that, by all means. So a few different ways to do that question. Number 4. Here's a satellite. Yeah. I don't care about most of this, right? We rarely do. What's the question say? Oh, here's a force, here's a time, what's the change in speed? Force and time, think impulse. We're looking for delta V, it's F times delta T over M. All we're going to do here is multiply, oh, wait a sec, the force is in pounds? That's odd. That's okay. 0.2248 pounds tells us 0.2248 pounds is 1 Newton. Well, then 6 pounds is X newtons. The X goes up, the 0.22 goes down. Now, I'm not sure exactly what that is in newtons, but once you have it, you can sub it in here, multiply by the time divided by the mass, and we get an answer of A for that. Some of you are really good at looking at this and saying, okay, 0.2248 pounds, 1 Newton. I want to convert from pounds to newtons. I'm going to divide by 0.2248. Some of you are really good at things like that. I'm not particularly good at things like that. Not. Whenever I see a conversion like this, especially a strange one, I find it easier just to set up a little ratio like this. Okay. But you can also go kind of trial and error, right? You can multiply and see if it's reasonable. Okay, if it's not, well then it must be the vibe. Right? 5. As the orbiter moved at 5,000 meters per second, short burst of fuel, direction perpendicular to its motion. I'm going to actually just make a little bit of space for this one. I need some more space to work. All right. So, listen, it doesn't matter which way it's going. This is one of those perpendicular things. I think this happens tomorrow, by the way, when you're not given directions, it just says perpendicular. You get to choose, right, as long as they're 90 degrees, as long as they're normal to each other. I'm going to say the 629 orbiter is going this way at 5,000 meters per second. And this is where it releases the fuel. If it's going to the right and it releases the fuel perpendicular, the fuel is either going to go up or it's going to go down. I'm going to make it go up. That's the fuel. And it has a momentum of 1.37 times 10 to the 5. Now, object number 2, which is what's left of the orbiter, is going to go down like this. And the mass of that orbiter, it tells me it doesn't change significantly, so I'm going to keep it as 629 kilograms. Now I want to find the angle at which it's deflected from its original direction. This is the original direction, so this is the angle that it's deflected. All right, X and Y components. Let's say PI equals PF. Let's say 629 times 5,000. An object before, 0 for this guy, plus 629 times V2F. Oh, look at that. V2F is just 5,000. So it keeps going at 5,000 horizontally. The Y component, we say 0 initial momentum equals, oh, look at that. We don't have to multiply M times V there. We've already got it. 1.37 times 10 to the 5 plus 629 times V2F. We solve for that. Solve for that. I don't know what that works out to be. I don't have that written down. Anybody got it? Gonna make me do it? Negative 1.37 times 10 to the 5 divided by 629 gives me negative 217.806. Now we just say 5,000, 217. We're solving for that angle. So it's the inverse tan of 217 over 5,000. That's going to give me a small number, right? Looks like to be 2.49. Somebody just said this one, 87.5. If it was, you just found the wrong angle. You didn't find the angle from the way that it was moving originally. It's measured from its original direction. What was that, 5? Oh, 2 more. Yeah. Thought it was almost over. 2 more questions. Getting there. Okay, let's do number 6 then. Oh yeah, this one. I remember this one. This confuses people. Space shuttle astronaut has a mass of this, but she's holding a can of spray, so really her mass is not 110, really it's 130, right? And then she sprays a little bit. She releases 3 kilograms. We're going to say mass total. Oh, she's at rest, isn't she? Yeah, she's at rest. Yeah, so the initial momentum would be 0, M1 V1F plus M2 V2F. She releases 3 kilograms of gas. Ooh, she releases 3 kilograms. That's a lot of gas. She releases 3 kilograms of gas, 3.0 kilograms times 15 meters per second. Wow. At 15 meters per second, what's her mass now? She's still holding the can, right? What is it?
122.
127. Yeah, 127. It's her and what's left of the can of gas, right? Or of spray. So 45, take that over to this side. 45 divided by 127 gives me 6 was a 0.35. Okay, we're almost done for real this time. Number 7. Explosion of a stationary object produces 3 fragments that move away from each other at the speed of fragment c. Oh, look at this. Guys, this is one of those ones where we're given the unknown angle. Remember those? We talked about that? You're given that angle. You can pretend you don't have it. You can just ignore it. Or you can save yourself a little bit of work by taking a shortcut with it. What did you guys do? Did you guys use that angle, or did you just pretend you didn't have it? How many of you guys took the shortcut? So most of you just took the longer way. That's fine. Like I said before, we have the 100 minutes to this test, right? You have lots of time to not take the shortcut. All right. What do we got here? No funny angles. Well, there is a funny angle, but that's what I'm trying to find, so that's okay. Let's say x is pi equals pf. 0 initial momentum equals 0 for object 1 plus 2 kilograms times 44.6 for object 2 plus 4 kilograms times V3F. V3F works out to be negative 22.3. And if you want, you can take this shortcut. The x component is 22.3. This angle is 37.2 degrees. Sine 37 is equal to 22 over V, solve for V. That works just fine. Or you can do it the way that we usually end up doing it. Say the initial momentum is equal to 0 again. Equals m1, 3 times 39.2 plus 0, because the second object is on the x-axis, plus 4 times V3F. Divide that by 4, negative 29.4. And then finally, it's just 22, 29, and we're looking for this. Pythagorean theorem, right? If we did it x component and then this, or if we do it x component, y component, and then resolve them, doesn't matter. We get the same answer, 36.9 meters.